So what happens in a convolution layer? So we have an input image. So for simplicity, we are considering a 2D image here. We have an input image. This is an input image represented by a 2D matrix. So we apply this convolutional kernel. This is a convolutional kernel or filter. We apply this convolutional kernel on this. We apply sufficient padding on this image. Whatever padding is required, we apply that padding, and we consider this kernel. This is one kernel, and we apply this kernel on this image with with required stride. We get this right here. I'm assuming padding as 1 and stride as 1, so we get this output image. This is output image, right? By performing this convolution operation, I get this image, right? Now when I get this image, I have elements here. On these elements, on this all the elements of this output image, we apply activation function called as ReLU, right? Like ReLU activation function, we apply the activation functions on this image, and then we get this final image, right? This is the final image with applying ReLU activation, right? So the sequence is, we have an input image. On this image, we perform padding. If required, then we apply this convolutional kernel on this image and perform convolution operation. We get this image after performing convolution operation, and on that we apply ReLU activation function on each element, So how do I get this image? Performing element-wise multiplication followed by addition, right? We multiply this with this, this with this, this with this, and add all of these in order to get this. And on this, we apply ReLU activation in order to get this, right? So this is the result of applying one kernel. I may have many kernel in this layer. I may have many kernels, like we have shown here too. This is another kernel, right? Because this kernel might detect the horizontal edges. So this kernel might detect the vertical edges. So for detecting different edges, we may have different kernels, right? So we may have more than one kernels in the same layer, right? We can apply multiple kernels on the same image in the same layer, right? So usually these two things are shown as a single matrix. They are not shown as a different matrix, right? I just showed here for understanding purpose, but they are normally shown as one matrix. This is the matrix in which we have got the convolution result, and on that we have applied ReLU activation, right? Similarly, this is result of applying second kernel, right? Okay, so let's see the image. Let's see the actual architecture, right? So if you see here, this is the input image, and here we have, these are the kernels, right? So these are the kernels here. Size of the kernels is 5 by 5, 5 by 5. But there are many kernels, right? So we can have many kernels here. The size of the kernels is 5 by 5, but we can have many kernels here, and those kernels will result in the different images, right? So here you see we have here n1 channels here, right? N1 channels, N1 kernels we have here, N1 kernels, right? And those are resulting in those N1 images, right? So, right. Similarly, here you have N1 channels. Again, here you have N2 channels, right? Here you have N2 channels, right? So that means we can have many kernels in an image, right? So each kernel will result in a different image, right? So the purpose of this is for detecting vertical edge, you may have one kernel. For detecting horizontal edge, you may have another kernel like that, right? So this is the convolution layer here, right? So this layer is the convolution layer. This layer is the convolution layer, right? And on that convolution layer, we are performing max pooling, the another operation which we saw, that is max pooling, right? We perform convolution operation here, right? We perform convolution operation here, and then we are performing max pooling operation here. This is max pooling layer. Again, we have a convolution layer here, and then max pooling layer. So this is how convolution layer looks like, right? Convolution layer, then max pooling layer, the convolution layer, and the max pooling layer, right? So this is how convolution layer looks like. And then finally, the output of this final layer is flattened. Flattened means it's unpacked, right? Unpacked. That means if the size is n by 4 by 4 by n2, so it will be made one dimensional. Let's assume n2 is 2, for example, n2 is not 2, let's take n2 as 10. So this will be, total values here will be 16 into 10, 160, right? So total values here will be 160. So those will be unpacked in a single vector like this, right? So, so that is called as flattening operation, and then that will be fed as the input to this neural network, fully connected neural network here, right? So till here we have only convolution, max pooling, convolution, max pooling. So we have many layers of convolution, max pooling, convolution, max pooling, right? And each layer performs, for example, this layer may perform the task of detecting edges. This layer may perform the task of detecting, let's say, the parts, right? This next layer may perform the task of detecting colors, and final layer may perform the task of detecting, let's say, complete object, right? And then finally, after flattening, that is fed as input to the fully connected neural network, and that neural network classifies what kind of object it is, right? So that's how the convolution neural network works.